Hello, today I'm going to talk to you very briefly about half-life. We're not going to cover half-life in a lot of detail in this class, but you will see the concept again if you take AP Chemistry with me, and you may have seen it already in Ps as well if you took that class. So half-life is basically just how long it takes for half of a reactant to disappear or to be consumed. Right? So here we have a graph of reactant concentration versus time, all right? And then the half-life could be in seconds or minutes or hours, it doesn't matter, but it'd be some unit of time. And then you could have a concentration in molar, which we'll get to later in the semester, or it could be a number of particles, or it could be a unit of radioactivity, or it could be a percentage of how much is left. But in this particular graph, we have molar, all right? And so it takes, so if we start at 0.1, half of that would be 0.5. And so the amount of time it takes for half to go away is 100 seconds. Okay? And then when we're at 0.5, half of that would be 0.025. All right, 0.05, sorry, to 0.025, right? And that's also from 100 to 200 seconds. So a half-life for nuclear reactions is always going to be constant. That's not always true for chemical reactions, but that's outside the scope of this class, all right? So you could use a plot of data that plots concentration versus time to figure out the half-life, just visually inspecting. Or sometimes a problem will give you the half-life. So we're going to do an example like that. All right, so the example that I put in your note packet is if a sample of radioactive isotopes has a half-life of 1 day, how much of the original sample will remain at the end of the second day. So anytime you're doing a problem like this, where you're trying to either figure out how long has passed or how much is left, all right, those are basically the two options, you're going to make a table of time that's passed versus the amount that you have, okay? So in this particular problem, what we know is the half-life, okay? So what we'll fill in terms of time will be on this side, and it'll be in terms of days. And then this didn't give us an amount of stuff, so that we would just assume if we're trying to find how much is left, that we started with 100%. Okay, so at 0 days, that would be when our experiment begins, we have 100% of our sample. Okay, so if it had given us a starting concentration, that's what would go here. All right, at the end of 1 day, we have half of that left because 1 day is our half-life, and then it would go down by half each time. So this column is always going to go up by the half-life each time, and this one is going to go down by half each time. So after 2 days, which is what our problem is asking us, we'll have 25% left. We could keep going, all right? This problem asked us at about the end of the second day, so 25% would be our answer, right? But we could keep going. You'll notice that if we keep dividing this by 2, it never quite gets to 0. So theoretically, there's always going to be some left, even if we go through multiple half-lives.